I'll take that as a no. Yes.
10.450.
So guys, this is section 10.4, number 50. Ew. Okay, cool. And they ask us to rationalize the denominator. Rationalize the denominator. What the hell's that mean?
To like simplify it?
Yeah, I like it, sort of. Somehow cancel the root out. What is it that I call it? Anybody remember?
Wait.
Something. Complete the root.
Quint.
Complete the root. How many 2's do I have in there right now? One. How many do I have? I have 1, 2 in there. How many do I need? Total, 5. So I need 4 more. Okay, I like it. See, I mean, don't make more of this. Why am I allowed to give it 4 more 2's? I can't just do that in general, right? If I see 3/5 somewhere, can I just go, I don't like that, let me multiply by 5? No. You can't just do that. So what is it that allows me to give this guy 4 more 2's? Because I'm going to do it to the... Also, I'm going to also do it to the... What makes it legal? Yes. So why am I allowed to take 2/3 and multiply the bottom by 2 as long as I also multiply the top by 2? Because what did I just overall multiply by? 1. And I'm always allowed to multiply anything I want to by 1. What does 1 look like? 1 looks like 2 over 2. It looks like the 5th root of 2 to the 4th over the 5th root of 2 to the 4th. That's 1, isn't it, so far? That's 1. I just multiply by 1. It's just a special form of 1 that lets the bottom become nicer. So it's a 5th root, which means I need 5 of everything, or how many? I can have 5 of everything, or what's the next good power to have that 5 would work with? 10 or 15 or 20. So I've got 7 b's at the moment. How many more b's do I need to make it a number 5 works well with? How many more b's do I need? Does 5 go into 7? No, but 5 does go into 10. So how many more b's do I need? 3. I mean, that's the base. When I say rationalize the denominator, you think, what's the root? How much more do I need to give this so that'll work? So I need 4 more 2's and 3 more b's. As long as I do the same thing to the top and bottom, it's legal. So on the top, you just get whatever the hell that is. What is 2 to the 4th? 16 times 3. 16 times 3.
30.
48. A to the 4th b cubed. See, the top just gets all the shit just slams together because it's not the top. That's not my focus. What's the bottom become? The bottom becomes 5th root of 2 to the 5th, b to the 10th. See, now I can do the bottom. The top is this bullshit here. Just kind of like the trash pile. Just had to throw all that stuff up there just to make the bottom nice. And the bottom becomes what now? 5 goes into 5. 1. 5th root of 2 to the 5th is 2. What's the 5th root of b? 10. B squared. Yes. Did we make the bottom look nice? Mm-hmm. Yes. So whatever else happened to make that happen is fine. Does the top look worse? That's fine. It's kind of like if you clean one place up, you're going to have to put the shit somewhere. So that looks really great, but just don't look over there. Don't open that closet. Right? So we made the bottom look nice, but the closet, don't look in there. It's a lot of... Ugh. So don't make more of that than it is. It's simply, what root is it? How much stuff does it need? How much stuff does it have? How much more stuff does it need? It's got 1, 2. It needs 5. Give it 4 more 2s. It's got 7 B's. It needs 10 for 5 to go into it, so let me give it 3 more B's. There's nothing more to it than that. That's it. That's why I like calling it complete the root. Give it what it needs. Yes?
55, please.
Oh, you're going to make me do all the... I'm not going to do all the last ones. Jeez. 55, just to let you know, there's simplification you can do right off the bat. What's the square root of 9?
Sorry?
Yeah. And what can I do with the square root of 20? So I get 2 square root of 5. That's on the bottom in that problem, number 55. And what's the square root of x squared? Assuming that it can't be negative, it's x, right? So the very first thing I do in number 55 is do all the parts I can do. I'm just going to be left with one thing in the root. And then I can just take care of that directly. The thing that I hate seeing is I always get somebody... I give you a problem like square root of 2a over square root of 3b. I say rationalize this. So what the student does is they say, all right, let me just square the top and the bottom. Right? Because sometimes teachers say it too simply. We say do the same to the top and bottom. But are you allowed to square the top and bottom of something? And it stays the same. What if you square the top and bottom of 1/2? What do you get? 1 squared is?
1.
2 squared is?
4.
Is 1/2 equal to 1/4? That's bullshit. You got to multiply or divide the top and bottom by the same thing. If I square 1, I multiply the top by 1. If I square 2, I multiply the bottom by 2. I didn't do the same thing to the top and bottom, did I? So you can't square the top and bottom. It's not allowed. I got to multiply the top and bottom by something. Okay? So for example, if I had 6th root of 5b over the 6th root of 16a4b2, start with the easy part. How many more a's would I need for the bottom?
2.
Does everybody see that? It's the 6th root. I can only do it if there's 6 things. So let me just look at the a's first. I'm going to leave a little room for the number. How many more b's do I need? 4. Does everybody see that? Why do I need 2 more a's and 4 more b's? Because then that makes 6, and then the 6th root can do it. Oh, yes?
Is it like the same as basically like subtracting it from 6 and making it 2 after 8?
Of course, yes. 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 6 doesn't go into 4. Well, how many more a's do I need so 6 goes into it? I mean, 2 more a's to make it 6 up here. Right? That's it. That's it. Why can't I do the cube root of 9? Because 9 is only made up of 2 threes. And how many 3's would it need? 3 3's. So if this was on the bottom of something, I can multiply by a cube root of 3. Because that's what it's missing. It needs 1 more 3. So I need a total of 6 things for it to be able to be done. There's 4 a's, so of course I need 2 more. There's 2 b's, of course I need 4 more. Now do I need 4 more or 5 more 16's? What is 16 already made of? Okay, 16 is 4 times 4, which is... How many 2's do I already have? 4. How many more do I need? 2 more. So that's it, guys. If this was a 7th power, I would have given it 3 more a's, because then that would have made it 7, and 7 can go into 7. If it was an 11th power, I would have given it 9 more b's, because that would have made it be 11, and 11 can go into 11. That's it. That is all it is. You guys are trying to make it more than that, and it isn't. It's just that. So on the top, I'm going to get, what's 5 times 4? 20. That's a b there. I didn't really want it. That was too bad. A squared b 5. And what do I get on the bottom? I get 6 root of 2 to the 4th times 2 squared is 2 to the... How many 2's do I have? 4 here. 2 more. So I got 2 to the 6th. A 4 times a squared. B squared times b4. And the 6th root cancels all those. How would I rewrite? So I get this on the bottom. I get 2ab on the bottom. Right? On the top I get this thing. How would I rewrite 6th root of a6? That would be a to the what power? True, but go there in steps. It would be a to the, what's on the bottom? 6. And what's on the top? 6. So it's a to the 1st. Do you see why that's why I can do this? A radical is a power. It's a fractional power. That's why I can divide this into these. So that's why if I can make all the powers inside 6 powers, or 12s, or 24, so whatever 6 goes into, I can do it. So then what do I do if it isn't 6? Well, I give it what it's missing. And it's legal as long as I do it to the top and the bottom. All right, that's enough of that. You guys got to get in there and try them out. Okay, anything else from homework stuff? No, okay. So last time we got into stuff like this here. Let's see. So please, dear God, this is not 5 cube root of 70. Can you see where that came from? Mm-hmm. Somebody just went 2 and 3 is 5, and 54 and 16 is 70. What? You can only combine things if they are like terms. These are very much not. I've got 2 of these plus 3 of them. This is like 2x plus 3y. But these aren't variables. They're numbers. So sometimes I can do something with numbers. If it was x and y, I couldn't do shit. If I said simplify 2x plus 3y, you'd circle it and say next. I'm done. I was done before you gave it to me. This is something I can maybe do something with. What can I do with this? Break it down. What's 54 break down into? What's a nice number? Say again? Well, why is that no good? Can I cube root 9 or 6? So what's the number I can cube root? 8. Does 8 go into 54? What's the next number I can cube root? Why can I cube root 8? Because 8 is 2 cubed. So what's 3 cubed? What's 3 cubed? 27. Does 27 go into 54?
Yes.
27 times 2 is 54. Why am I choosing 8 and 27? Because the next step, I'm supposed to be able to take the cube root of something. So of course I'm going to try to divide this by numbers I can do the cube root of. So I can break this part up. So it's 2 times the cube root of 27 times the cube root of 2. Now what about 16?
8.
Why 8 better? Because 8 is cube rootable. So I'm only going to use numbers I can cube root. So 16 is the cube root of 8 times the cube root of 2. What is the cube root of 27? 3. What is the cube root of 8? 2. So I get 6 cube roots of 2 plus 6 more cube roots of 2 makes 12 cube roots of 2. Bam. So, please, you know you can't add them unless they're like terms. But when I see q root of 54, you have desperately got to, by now, say, oh, I can break that up. And what are you hoping for? You're hoping to have some extra piece that is like terms. So yeah, I got so many cube roots of 2 and so many cube roots of 2, so I can put those together. It's like if I said add 24/40ths to 7/5. Now you could build this up, but can't you break this down? So right now, are they like terms? No. But if I reduce this, 8 goes into this, 3, 5. Now I can do 10/5, and I can make it 2. It's sort of the same idea. I can't put these together yet, but let me break this down. Maybe what's left is like terms with the other piece too. It's the same idea. Okay. So that was in 10.5. The next part of 10.5 dealt with stuff like this. Even if you don't like the radicals in there, what's your brain immediately say you should do? What's that look like? Yeah, distributive. I like it. FOIL, unfortunately for most of us, but it's just distribute each piece, right? So, but what do you do when you do 2 rad 3 times 4 rad 5? Say again? So help me out. What operation did I just say? What am I doing? This
Multiply.
times this. So what is it going to be? 8. Square root of 15. Why doesn't that 2 do anything to that 5? Because the 2 doesn't have a radical, right? So when I do, what's 2x times 4x? 8x squared, right? And you don't stop to think, well, why didn't that 2 multiply by that? Oh, what? You do you combine the things you can. So I can multiply the numbers and I can multiply the radicals. Kabam. And you keep going. What am I going to get down here? 2 rad 6. 4 35. Rad 14. Can you simplify any of these? I'll tell you real quick. You know what went into them, see? You know the parts of these. None of them are going to break down. If they could, then something would have broke down up here. Are there any like terms? Are there any other rad 15s? Mm-hmm. No, there's no like terms. But part of your brain says, I can't be done. But you so desperately are done. There's nothing else you can do. You can't simplify any radicals. There's no like terms. You stop. Okay. Man, you guys are ready for Thanksgiving, man. You guys are like, why are we here this week? What's wrong with you people? I appreciate you're here. Okay. That's the first step. So that led us to this kind of thing. What's kind of special about that? Yeah, it looks like different squares. The middle terms are going to cancel, right? So 2 times 2 is 4. What's rad 7 times rad 7? 7. Don't put 49 or anything. And then you would get 2 rad 21 negative and 2 rad 21 positive, and they would cancel. The middle terms cancel. And what is this? Rad 3 times rad 3 is 3. So then you get 28 minus 3 is 25. Very ugly number times a very ugly number becomes 25. That's pretty damn nice. What was the idea of this called? This is this guy's conjugate. I love it. Right? Not conjugal physics. So that led us to a way of handling something like this. How to rationalize this guy's denominator. What would make this become a nice number? Its conjugate would. Because the only place a radical could still be left alive would be in the middle, and if I multiply it by the opposite sign there, the middle terms will cancel. That's why the answer comes out nice and rational. No radicals left. So what would this guy's conjugate be?
Root 5.
Cool. So go ahead and finish that up. All right, let's see what you get. So here you get
Root 15.
root 15
Minus.
to root 6. I like it. Rad 5 times rad 5 is 5. This and this cancel. Right? This will be 2 rad 10 minus 2 rad 10. That's gone. Negative 2 times 2 is 4. Rad 2 times rad 2 is 2. So I get rad 15 minus 2 rad 6. So I don't have to write too much. 5 minus 8 is negative 3. I like it. And you can stop there. Technically, you should bring the negative up and change the signs up here, but this is fine. That's one of the funkier things, is how to handle something with a couple terms on the bottom. It's got to be this conjugate idea. All right. Let me try this. It's my day, my turn. I'm surrounded by these video playing fools. I'm going to be a video playing fool again today. There's this really cool video. I think I told you about it. It's a good thing because it's got a lot of nifty graphics in it. The person actually doesn't speak on monotone, which is nice. I had a teacher that would, today we're going to talk about math. And I was, oh my God. This guy is almost a little too animated, but let's see. He's going to talk about the idea of non-real numbers. I think I told you I had a nifty little video. You all right?
Yeah.
I like it. You will forever be changed after today, so be ready. He kind of makes a point a little quickly. I'm going to kind of go over it deeper later when it's done. Let me look it up real quick. There you go. Brought to you by Panasonic. Shoot. Oh, where are you? There we go. There we go. Oh, you can skip the ad. That's nice. Can you do the base care?
Actually, is correcting everything as I'm writing.
Grammar errors, spelling errors. If you can help me find the right words to use so I can say what I want.
Too bad they don't have this for now.
Let's say we're given the function f of x is equal to x squared plus 1. We can graph our function and get a nice parabola. Now, let's say we want to figure out where the equation equals 0. We want to find the roots. On our plot, this should be where the function crosses the x-axis. As we can see, our parabola actually never crosses the x-axis. So according to our plot, there are no solutions to the equation x squared plus 1 is equal to 0. But there's a small problem. A little over 200 years ago, a smart guy named Gauss proved that every polynomial equation of degree n has exactly n roots. Our polynomial has a highest power, or degree, of 2, so we should have 2 roots. And Gauss's discovery is not just some random rule. Today we call it the fundamental theorem of algebra. So our plot seems to disagree with something so important, it's called the fundamental theorem of algebra.